Okay, so today we are going to start talking about the simplex method, and this should be the exact same thing we did last time, except for we're going to do it in a calculator. And we use the calculator because we're going to have too many variables than just x and y. So it says the simplex method is the method of maximizing or minimizing a linear function, so we're still dealing with lines, of several variables. So not just two, we're having several under several different constraints. So it's not just going to be, a couple, it's going to be a little bit more than that. And it's still going to be on other linear functions. Okay, so that's not changing. So basically, that we're going to have not just x and y, we're going to label them a little bit differently. Now there are many steps to this method, we're going to break it up. So the first thing we need to do is that it has to be written in a standard form. Okay, so basically it's going to be, if the function is to be maximized, we're going to follow this route. First off, they all need to be non-negative, meaning they have to be greater than 0. Which is what this says right here, greater than or equal to 0. Okay? Once we know they're all non-negative, we have to rewrite it so that all the variables are on one side. Should be a plus. Okay, however many different x's you have, all the variables on one side, some inequality, and then your constants. So we want the constants over here, and we want the variables on the left, the constants on the right. That's what we're looking at. Now, if you noticed, I didn't call them like x and y and z. Basically, I'm putting all variables in terms of x. All variables in terms of x. So that x1 just means the first variable. And then x2 is the second variable, and then x3 would be the third, and so on. Okay, now what's going to happen is that because we're going to change an inequality to an equation, we have to pick up some of the slack that's going to happen when we do that, because inequalities and equations are different. So this slack variable is a non-negative, once again, non-negative variable that we're going to add to a constraint. Okay, now each slack variable is different. So we'll add maybe S1 to the first equation, and then we'll add S2 to the second equation, and we'll add S3 to the third equation, and so on. And all they're going to do is they're going to help us move between an inequality to an equation. Alright, so here's the first chunk of our steps. Steps 1 through 3. We are going to determine our objective function. Remember that's your z equals. We're going to write our constraints. So those are the equations or inequalities that are happening. And then we're going to change each constraint to an equation by adding that slack variable. So we're going to add our S1, S2, and so on to each inequality. Okay, so this says convert each inequality, so that's the ones with the less than or equals to an equation, which is our equal to, by adding that slack variable. So we're going to do one at a time here. So this is just one equation. It's going to have one slack variable. The x part doesn't change. And all we're going to do is add S1, change it to an equal sign instead of less than, and then bring that 6 down. So all we did was insert one slack variable. Alright, we're going to do the same thing on the next one. Nothing's going to change in this inequality. x1 stays the same, x2 stays the same, x3 stays the same. All we're going to do is insert slack 1, change it to an equal sign, and then we have 17. Okay, so this was just 1. Now what happens is if we have a full maximization problem, okay, we have to add more than one slack variable. So that first part says determine the number of slack variables needed. Okay, this is going to be part A. So we're going to determine the number of slack variables needed. And then we need to name the slack variables. So that's going to be part B. And then we're going to use them, like we did in the example above, to change them into the equation. So that's going to be part C. Okay, so in part A, alright, I'll look and it says minimize this function subject to these 3 constraints. Okay, so now there's going to be a slack variable per constraint. So that means part A is we need 3 slack variables. Okay, then part B is going to be naming them. And what we're going to do is we're going to have S1, S2, and S3. So that's part B. We named them. There's one for each equation. Now, when you go into part C here, remember, we're only looking at the constraints. We're not even dealing with that z function. In the first constraint, nothing stays. Nothing changes. Keep it all the same, and then we're going to add S1 to the first constraint. Okay, and then now I'm going to leave some space. I'm going to change my less than to an equal sign, and then 15 stays the same. Okay, and then I'm going to move on to constraint number 2. Okay, now when I move on to constraint number 2 here, that's going to use slack variable 2. But I'm going to skip where slack variable 1 is right here. I'm going to leave a space. I'm going to do plus S2, change my less than to an equal sign, and then 35 gets brought down. Alright, now time to move on to constraint number 3. So once again, x and x2 stay the same. Now I'm going to leave a space for S1, I'm going to leave a space for S2, and I'm going to add S3 down there at the end, change it to an equal sign, and then 20 comes on down. Okay, now the reason why I kind of staggered that is so that you can see right here that that first constraint is the only one with an S1, and then the second constraint is the only one with an S2, and same for the third. Now the very last thing we have to add on here is that with part that's right up there at the top. So we got to make sure we remind ourselves that all these numbers are non-negative. So this is what the original part says. It says x1 is greater than 0, and it says x2 is greater than 0. And then we need to add each of our constraints being greater than 0, because remember, they're non-negative, so we have to make sure we say that. Okay, so we're going to do the same thing here with part B. Alright, so the first thing we had to do was say how many we needed. Okay, there's only 2 constraints right here. So we only need 2 slack variables. And then we need to name them, and they're just going to be S1 and S2, because that's all we need. Alright, and then part C, we're actually going to add them in, change those inequalities to equations. So in that first constraint, it stays 7x1 plus 6x2 plus 8x3. Now you need to throw in plus S1 there. Leave yourself some space. You're going to do an equal sign and then 118. Okay, and then for the second constraint, everything stays the same. 4x1, 5x2, 10x3. Leave a space for where S1 is. Put in your S2, change it to an equal sign. Bring down to 20. Okay, remember you got to include the width. You got to make sure you tell me that all the variables used in my new constraints are non-negative. So those three x's stay the same, and we need to add s1 is greater than or equal to 0 and s2 is greater than or equal to 0. Okay, so that's the first step. We changed, that was actually beginning step number 3 because the other two were already done for us. We converted our inequalities, so those two constraints in the red, to equations by adding slack variables, which is part C. Okay. Go ahead and flip over. Okay, so now that these are equations instead of inequalities, we can actually use matrices to do the rest for us. Now, what's going to be created here is going to be called a simplex tableau. And all it is an augmented matrix with our constraints above the objective function. So we're actually going to put the objective function into our augmented matrix. So if you remember the augmented matrix, so we had our little brackets for our matrix, and then we normally did x, y, z. We had that vertical line. So our variables are on the left, and then our constants were on the right. Okay, now this is going to look very similar. Okay, so that was a augmented matrix. That's what this is. And then our simplex tableau, all right, is going to look something like this. So it's still going to have our brackets, except for it'll be column 1 will be x1, and then column 2 will be x2. And then you have to have a column for your slack variables. And then you have to have a column for the z of your objective function, and then you're going to have a vertical line, and then you're still going to have your constants over there on the right hand side. Now, the other thing is it said constraints above your objective function. So the very last row, so there's going to be kind of some lines inside. That very last row is going to be your objective function. And then all the rows above it, these are all going to be your constraints. All right, so let's look at the next example here. So it says now we're going to create that tableau. Okay, so it says introduce slack variables as necessary. So that's going to be step 1. Then it says then write the simplex tableau for each linear programming problem. So I'm going to need an S1 for that first constraint. I need an S2 for the second constraint. All right, now the other thing is if you notice up here in this right hand corner is that the x1 and x2 and the z are all on the same side. So what I need to do right here with my objective function is that I need to move this 7x over here with z, and I need to move this x2 over here with z. So really my objective function should look like negative 7x1 minus x2 plus z equals 0. And we're going to come back to that. But first, let's add in our slack variables. Okay, so our new constraints are 4x1 plus 2x2. And then I'm going to add in my first slack variable. I'm going to change it to an equal sign. I'm going to bring down my 5. And then I have x1 plus 2x2. And then I'm going to add in a space for S1, and then I'm going to add S2 here, right, an equal sign. And then I'm going to bring down my 4 for that second constraint. Now I'm going to rewrite my objective function below my constraints, just like it said up there. So I have negative 7x1, line everything up, minus x2, okay? There's no s's in your objective function, but there is a plus z way out here at the end, and you're going to keep that an equal sign, and then that one's equal to 0.